Number 32 from Segel. What are the concentration of ammonia and ammonium chloride in a 0.15 molar ammonium buffer pH 6.9? So you have ammonia and ammonium chloride in the ammonium buffer pH 9.6. So first thing to notice is that ammonia and ammonium chloride is actually the conjugated pairs. So in this question, it requires you to use the Henderson-Hasselbalch equation to solve for the ratio of between ammonia and ammonium chloride at the right pH, which is 9.6. So talking about the ammonia and ammonium chloride, I would like to start from ammonium chloride because ammonium chloride in water will be ammonium ion, and then it can protonate to give you ammonia and proton. So this will be the value of pKa. So the questions give you the Kb value, which is equal 1.8 times 10 to the negative 5. So your job is to change Kb to pKa in order to use in Henderson-Hasselbalch equation. And pKa, if you calculate it, right, you will get pKa equal 9.26. So Henderson-Hasselbalch equations, pH equal pKa plus log B over A. So B is the base, so it's actually ammonia, and A is the acid, is actually the concentration of ammonium ion. So pH is equal 9.6, pKa is 9.26 plus log B over A. So to calculate the ratio of B over A here, in the lecture, I think Dr. Hughes gave you the shortcut, but I would like to explain you the full explanation of how you can solve for B and A. So log B over A will be equal 0.34, and then B over A will be 10 to the 0.34 equal to 0.18. Okay, to solve for, because this is the ratio, right? B and A is the ratio, and one thing to keep in mind is that in any case, A plus B will be equal to 1 or 100%. So to solve for B, if you want to solve for B first, you have to change A in terms of B. So you want to solve for B, so you have to change A in terms of B, which will be equal 1 minus B here. So B divided by 1 minus B will be equal to 0.18. Then you just move so for B. So B will be equal to 0.18 minus 2.18B. And then you just move to 0.18B to add in the another side of the equation. You will get 3.18B equal to 0.18. So B will be equal to 0.18 divided by 3.18. If you want to solve for A, So you have to change B in terms of A. So you will get 1 minus A divided by A equal 2.18. Again, so for A here, then 1 will be equal 3.18 A. So A will be equal 1 divided by 3.18. So again, if you first solve for B, you get B equal 0.68. And then you can solve for A using 1 minus B. It's gonna be the same anyway, right? So if you want to solve A after you solve for B, so you use A equal 1 minus 0.6x6. So this will give you the same amount that you calculate from above panel. So once we get the ratio amount for B and A, so the ratio is actually like equivalence. It's not the same as mole or molar. So the questions ask you to calculate the concentration of either ammonia and ammonium chloride. So because the value here and here is just the equivalence or ratio. So to calculate the concentration, you need to take the molarity of the ammonia buffer into consideration. So the concentration of ammonia will be equal to the ratio times by 0.15 molar. And for ammonium chloride will be equal 0.314 times by 0.15 molar. And the final answer will be this. Point 103 molar for ammonia and 0.047 molar for ammonium chloride. This is the final answer. However, if you want to calculate in morality at the first place, when you solve for A and B, instead of using A plus B equal 1, which refer to the ratio or equivalence, you can use A plus B equal 0.15 molar, because you know that anyway, ammonium ion and ammonia will be equal to 0.15 molar anyway, because it's composed into the ammonia buffer. So yeah, the total of ammonia and ammonium chloride need to give you at the exact 0.15 molar. So you can use A plus B equal 0.15 here, and then solve for, if you want to solve for A, it can be like 0.15 minus B. So B will be equal 0.15 minus A. That look like this, and then you can solve for B and A, and then the amount that you get will be the molarity instantly.